couple more examples from the review package. Number 9, 27m cubed minus 12m. So you can try first, as always, taking out a greatest common factor. Biggest thing you can pull out of here, so you can pull out an m from each of these. And it looks like you can also pull out a 3, because 12 and 27 are divisible by 3. So that leaves you with 9m squared minus 4. So when you distribute this 3m back in, you get 27m cubed minus 12m. So that's good. Now we're left with two terms here, and it's looking like a difference of squares. So you have one term that's positive and the other term's negative. And you can get 9m squared by multiplying 3m by itself, and you can get 4 by multiplying 2 by itself. So you can write 9m squared minus 4 like this: 3m plus 2 and 3m minus 2. So just to check, 3m times 3m is 9m squared, and then 3m times negative 2 is negative 6m. 2 times 3m is positive 6m. 2 times negative 2 is negative 4. So 6m minus itself is just 0, and then we're left with 9m squared minus 4, as we should. And then we've just got the 3m that sort of tags along for the ride. One more example. 16x squared minus 88x plus 121. Attempt to pull out a greatest common factor first. So it looks like you might be able to pull out an 8 from all of these, but the 121 sort of messes things up a bit. So if you try 121 divided by 8, you get a decimal, you get 15.125, so you can't pull out an 8 from these three. Next thing you can try, okay, well it looks like I can pull out a 4 from these, but again, 121 divided by 4 doesn't give you a clean answer, so 4 doesn't work. 2, same thing, 121 is not divisible by 2. So it looks like we've got a trinomial where a is not 1, and this looks pretty awful. If we were to attempt the x factor method or trial and error would be pretty awful. Same thing with x factor though. X factor, 16 times 121 gives us 1936. So you would have to search for factors of 1936, which could take a while. This turns out to be a perfect square trinomial. So you can get 16x squared from 4x squared, and then you can get 121 from 11 squared. But we need this sign to be negative. So the middle term for a perfect square trinomial is gotten by doing the first term times whatever the last term is multiplied by 2, but we need a negative sign here. So we could try putting a negative sign in front of the 11. So now 2 times 4 is 8. So 8x, and then 8x times negative 11 is minus 88x. So we can try writing this as 4x minus 11 times 4x minus 11. That's what the perfect square trinomial allows us to do. So we should check. So we have 4x times 4x is 16x squared. 4x times minus 11 is minus 44x. Negative 11 times 4 is minus 44x again. Minus 11 times minus 11 is positive 121. So this is our answer, and it works out.